and welcome back to the pricing channel for small businesses. In our last 4 videos, we have been promising that with proper pricing, you can achieve better business profitability. And in our last video, we talked about how pricing can increase profitability when your demand exceeds your supply, or when price is reduced in order to increase demand. And we even suggested making small price changes up or down in an attempt to find the sweet spot between profitability and demand. But in reality, making a lot of price changes and measuring demand can be a lot of work, which can take months and months to accomplish. And so you might wonder, is there an easier way to do this? And it turns out there is. So let's take a look at one way we can determine the best pricing to maximize our profits. To find the price that maximizes profitability, let's look at an example. And let's pretend that we own a business that manufactures tools, and that we've developed a new tool for some type of home repair. Now, it doesn't matter what the tool is or anything like that. It's just a new tool that we've developed. And it's a unique tool that has some advantage over other tools in the market that are selling for approximately $6 or $7. And so to find the price that we can sell our tool at to maximize our profitability, we need to first of all introduce some new terminology that we're going to use. Now, in a previous video, we've talked about what business profitability is in the following way. We talk about revenue, we talk about the cost of goods sold in order to produce that revenue, and then when we subtract that cost of goods sold from the revenue, we generate a gross profit for the business. And a metric that we can use is gross margin, which is simply the gross profit divided by the revenue. And in this particular example, we say that the business is generating a gross margin of 40%. Now, we can use a similar type of terminology to describe product profitability. Not the profitability of a business, but of a particular product within the business. And the terminology we use to differentiate that is price, the price of the product, the variable cost of the product, that is the cost of direct expenses required to produce the product so that we can sell it at a particular price. And when we subtract the variable cost from the price, we get something called the contribution. And this is analogous to the gross profit when we're talking about a business. And likewise, a metric that we can get from that is called contribution margin. And it's simply the contribution divided by the price, which in this example would yield a contribution margin of 40%. And so using these two sets of terminology, we can differentiate between whether we're describing business profitability or product profitability. So, let's return to our profit maximization process or problem. So let's assume, in this case where we're producing this new tool, let's assume that the variable cost to produce that tool is $5. That would be the materials and the labor, maybe packaging and those types of things. That would be the variable cost to produce a single tool. Now, we can introduce the tool to the market, and we can start out with a price, a market price for that tool, and then we can make some incremental price changes and measure how sales demand of the tool changes with changes in the price. And so if we did this a number of different times, this is the kind of data that we would generate. So we may have started off, say, at $10, and we decided to make some increments to go up to $12, and we also made some increments going down all the way to $4, and this is the demand data that we were able to measure at each of those price levels. Now we can take that data, and from each price we can subtract the variable cost, which we said was $5, and for each one of these price levels we can get the contribution, which is shown in the third column from the left here. And so for the first price of $12 for the tool, we subtract $5 and we get a contribution of $7, which is equivalent to the gross profit for the business, for a business example. And so we can repeat that for all the prices all the way down to $4, where when we subtract $5 variable cost, we get a contribution of a negative $1. Now the other thing we can do is to take that contribution number and multiply it by the demand number in the first column to the left. And so again, looking at the $12 price, we see a demand of 400 tools over some period of time. If we multiply that 400 times the $7 contribution per tool, then that says the total contribution for selling 400 of those tools is $2,800. And we can do that again for every price level. And we can see how the contribution, the total contribution, changes as the price changes. Now the interesting thing we can do with this data now is we can plot the total contribution on the y-axis of a graph versus the price at that contribution on the x-axis. And when we do that plot as shown here, we get a very interesting looking curve. And the most interesting thing about this curve is it reaches its maximum value at a point between the price of $8.50 and the price of $9. And so what we can say is, in between those 2 points is the place where our total contribution or profitability is maximized. And so what that means is that by doing this plot, we have found the price that maximizes the profit of our new tool. So there you have it. By plotting total contribution versus price, we can determine which price maximizes our profitability. Now great, you might say, but that's still a lot of work because we had 17 price points in that example. Isn't there even a simpler way to get to this? And it turns out the answer is yes. There are a couple of simple ways to do this. And we'll show you one today, and we'll save the other one for a later video because it involves a little bit of calculus. So let's take a look at the simple one right now. In the previous example that we looked at, all of those price changes would have taken months upon months to accomplish at a minimum. So to simplify the problem, we can use just 2 price points instead of 17. And so let's pick $10 and $9 as our 2 price points. And so we can start with the $10 price and measure the demand and find that demand is 2,000 units over a certain period of time. And then when we lower the price to $9, we can find that the total tool demand is 2,800 units over that same period of time. And what we can do then is take those two pieces of price demand data and plug them into a linear least squares program to find the line that goes through those 2 points. I hope you're familiar with the linear least squares process, and there are lots and lots of programs on the internet that can do those calculations for us. And if you're adept at using Excel, Excel has a linear least squares program built into it. But whatever you use, we can plot the points and use the linear least squares program to give us the equation for the straight line that goes through those 2 points, as illustrated on the chart on the slide. And we can plug various price values into that equation, where price is represented by the X variable, and generate as many demand values as we want, with the demand values being the Y variable. And we can take that data and see that data are the same values that we saw in the previous example, because it's the same line. The 2 price points, $10 and $9, generated the same demand as they did in the previous example, and so of course we get the same line, which then generates all the other same demand data that we saw before. And since the price versus demand values we obtain with our straight line are the same as we saw in the previous example, that means the price that maximizes our profitability here is also the same as in the previous example, where we saw it was $8.75 per tool being the price that would maximize the total contribution or the profitability for the tool. Now that is pretty simple. With just 2 points of data and a straight line assumption, we can pretty easily find that optimum price that maximizes profitability. And as you may recall, the assumption of the straight line came from our previous video where we talked about the reverse S-curve. Now, since we brought up some new terminology about pricing, namely price, variable cost, contribution, and contribution margin, let's use that information to solve some more pricing problems. And so we'll take a look at that in the next video. Meanwhile, please be sure and hit that subscribe button so you don't miss any of these videos. And I look forward to seeing you again.